All right, good morning, good afternoon, good evening. Welcome to Chain Fusion Live. This is a very special live from DFINITY Headquarter edition. I'm joined with the CTO of DFINITY, Jan Camenisch, and the VP of Engineering, Sam Burri. Really super excited. Guys, how are you feeling today after the third anniversary celebration yesterday?
A bit tired and
What a
exhausted.
question! Super hyped. A little bit rough voice here.
Was a great day.
So many great people. I guess people queued up outside in the rain. Some had to turn home because it was so full. Sorry to those guys, but it was a great day. Great people. It was a ton of fun.
Yeah, the headquarters.
People from the node providers, developers, community members, the DFINITY team, other builders, just from everywhere in the world. I think I walked away really motivated after this party, even though a bit tired today.
I think I've noticed the office is a little sluggish today. Productivity is going to be a little bit lower on this Friday.
Can you switch on the make me look younger filter, please?
I think I already did. Sorry.
Boy, that's how you look today.
Yeah, you can tell we're all feeling very jovial here at DFINITY. A phenomenal third anniversary party yesterday. Over 600 guests, like Jan said. It was tough getting everyone inside. The rain was a little bit of a damper in the morning, but awesome people from all over the world coming out. A lot of community members, a lot of developers, a lot of investors. So it's just awesome to meet them. But we're not here to talk about and reminisce over our party yesterday. We're here to talk about the new ICP Roadmap, which went live, it was, I guess, a week ago at this point, or about 10 days ago. Walk us through. So Jan, walk us through what was the thinking of kind of revamping the roadmap and kind of putting it all together in the format.
Well, the goal was totally to have the 4th year anniversary party 10 times bigger. So that was our goal, and then we thought, okay, how can we get there? And I guess it's all about marketing, and so we wanted to switch gears in marketing. So how we explain technology, how we can tell people what we build, how get them excited about it. And I guess in the past, just after launch, before the network went live, we had this milestone, sodium, Mercury, however they were called, where we just had that feeling because this is thing achieved, the community could understand, right? They would know, okay, here the first builders come, here more builders come, this kind of a sense of achievement. And after that, we were sort of chugging away, getting one more tech out there, improve this, but it was all a bit piecemeally kind of thing. And it was hard for people to get excited about it because it's not so clear what it really achieves, what's the context. And so we went back to the engineering and marketing drawing board and tried to figure out, okay, so how can we explain better to people what we're doing, what's the purpose of those things. And so that's why we said, okay, let's go back to this bigger milestone and sort of frame things around milestone, around goals. And for the team as well, right? So the team has, okay, next goal is this, next goal is this. And of course, we have a large team, so you can work on some goals in parallel. And so we divided up the whole roadmap in a number of work streams, like ICP platform improvements, Chain Fusion. I guess that's why we're on Chain Fusion Live today. AI. Yeah, you're bringing it up, so you helped my memory here that suffered a little bit last night. So Chain Fusion is one. And then privacy is another one that actually no other blockchain can do. So that's why we decided to also have a whole work stream on privacy. Platform decentralization, right? I mean, NNS, more boundary nodes, different structure of boundary nodes. Identity is a super important piece of the whole platform, right? It's I mean, if you consider other platforms, such not really comparable, but the Apple app ecosystem has apps. You can launch apps, you can have identity, you can have payment, and so that's why identity is actually a very important part of ICP. So that's a separate workflow. And of course, this space is all about digital assets, so that has to have its own separate workflow, and I guess we can talk more generally about each of those things if you want. But maybe the goal here today is really to talk about the milestone that we celebrated, and I guess the last one was governance. Maybe it was the last one. I forget.
Developer experience.
And that's
not
definitely
to be forgotten.
It's definitely not the last one. It just happened. Somebody has to be at at the end. But last but not least, developer experience, which was also bumped up yesterday because we had all these developer and they had a great experience, like a party. Maybe we achieved the first milestone there. Maybe a secret one. But there you go.
It was a double milestone win yesterday. Yeah, phenomenal. I love just how you guys broke down the roadmap into these different buckets, these different work streams, and it really, I think, helps plant in the minds of even a casual somebody who's just kind of curiously interested in internet computer. It helps place in their mind what is going on and what's to come. And it's, again, just the breadth of the roadmap is phenomenal. Because this is Chain Fusion Live, and because we celebrated Tritium, the very first milestone in this new roadmap yesterday, I'd like to just dive deeper into Chain Fusion. So, Sam, I was kind of wondering, in terms of like this term Chain Fusion, what exactly are we talking about when we say Chain Fusion? And give us some background on this term.
Yeah. Actually, the term Chain Fusion, we only really started using a few weeks or months back. But the work around this has started since Genesis, and that's, as we now know, 3 years ago. I think what we call Chain Fusion is the ability of smart contracts to sign transactions and interact bidirectionally with other chains, and doing so without relying on a single point of trust, so bridgeless. And this allows you then to fuse together the ICP superpowers, such as the scalability, low-cost transactions, and we can talk about all these additional capabilities to fuse this together with smart contracts on other chains. And that has two benefits, right? It brings new capabilities to other chains and other ecosystems, and it potentially or hopefully brings also developers to the ICP ecosystem, so that we have more people, more assets managed on ICP, and that drives up network usage. And frankly, it also allows our team and our ecosystem to step a bit outside of its echo chamber. So that's Chain Fusion. And we have, if we briefly look back, we have launched the threshold ECDSA signature service or solution in summer 2022, combined with the Bitcoin integration. We then realized that Bitcoin was still, of course, had low finality, very expensive transactions. As a result of that, the CK-BTC twin of Bitcoin on ICP was born, and that was in spring last year. And then we went on and were working on the similar solution for Ethereum. So towards the end of last year, we then, the NNS voted on CK ETH. So again, a twin of the Ethereum token on ICP. And built on that is now, and I guess we now come to what we also celebrated yesterday, this Tritium milestone, CK-USDC, which is a twin of the very popular stablecoin USDC on ICP.
Also, Kyle, if you click on the past features, like everybody actually sees all the features there. So right there, right? You see all the past work as well that we're of course very proud of.
You're very proud indeed. That's I guess what I covered. Yes, and that's what the roadmap should also show, right? It shows not only what's happening in the future, it hopefully also shows that this project has already accomplished a lot, and it gives you a bit of a vision and direction where things are headed, even beyond these fairly tangible milestones that are now on the roadmap. You also see what ideas are out there that we may pursue only in a few years or quarters. But I hope that answers the question about what is Chain Fusion, and yeah, maybe we should talk a bit more about why Tritium was so important.
Yeah, actually, coming back to these past features, because I think this is something that goes missed within the crypto industry. In terms of the number of, let's say, engineering hours that went into all of this work in the last 2 years, what would you guys estimate for like the amount of research and development that it takes to develop all of these past features over?
Let's say chain fusion.
Sam's got to go on fire up Jira with all.
No, I do an estimate, but I mean, if you look at the teams, and I mean, this is of course a lot of work by the R&D team. So you have researchers working on it, you have engineers implementing it, but then you have also a dashboard team that integrates it. You have a marketing team, you have a partnership team. I mean, it's really a cross-org effort. Kyle, you have been helping with statistics around this, right? So there's a lot of people that help. I don't know, I would say maybe, let's say 20 people at least for the last 3 years. So that's a huge effort that went into this. It's really a key, I would say, a USP of ICP to have these chain fusion capabilities.
I think, one of the things, just to kind of pat DFINITY on its own back, one of the things is there's really no shortcuts taken in this roadmap so far. And what I mean is, within the industry, we've taken shortcuts to, we've taken things that are hard and we've said, okay, well, if we add a little bit of centralization, if we add a multi-sig wallet into this, if we keep this code, in its own little private GitHub repo, then we can do things a lot faster and do things, maybe garden a little bit, walled garden a little bit. One of the things that really stands out with chain fusion is the lack of intermediaries and the fact that no corners were cut, especially with direct Bitcoin integration. I think it's probably worth, actually, Jan, would you mind just spending a few minutes just on how novel direct Bitcoin integration is for ICP?
Yeah, totally. And I guess so. I mean, for any of those tiles there or cards, however you want to call them, I think it's sort of the same for each one of them. But let's have a look at threshold ECDSA, right? I mean, on the one hand, if you go to eprint.icr.org, the cryptographers Hall of Fame kind of list of papers. I mean, you find a ton of papers on threshold ECDSA, right? It's not a problem that people have not looked at before. That's a well-known problem. But actually, if you dig in and look at the literature, none of these protocols actually really provides liveness in an asynchronous environment. That people were always making assumptions about the environment, because and really ECDSA is a bit of a bitch in terms of the cryptographic function, the cryptography, how it works. So if you do it in a threshold way, you have to do an inversion in the exponent to get very mathematical here. But that's actually very, very hard to thresholdize. Signature schemes like Schnorr are much easier. And so once you start implementing or want to really make something like that live and perform, and you have to really rethink the whole thing, right? How do I really do it? Because most of the cryptographic research is just looking more at some of those things, but not really end to end. So for threshold ECDSA, when we really plus minus around launch, I still remember Dom and I were having a conversation in the old Palo Alto office that, hey, wouldn't it be great if a canister could have Bitcoin, right? Of course, it's easy, right? I mean, you just have threshold signatures and you sign that. And yeah, in theory it's easy, right? But if then you really want to do it, wasn't just Jens and Victor first who spend weeks and months to dig through the crypto literature and really make a scheme that is live under an asynchronous environment, how the intercomputer is. Nobody else has that, right? All the other schemes out there, they're not live in an asynchronous network. And so that also means that, yeah, these things are going to fail, right? And so we cannot accept having functionality that is failed just because messages arrive a little bit later. So it has to be rock solid. And I think just to what you say, not cutting corners, really have to solve these things for the good. It has to perform. And of course, then that also means you just had two persons working out the details, but then you need to explain it to the engineers. The engineers need to make sure it's implementable. you do iterations there before you figure out what you want to implement it, how. And then also it has to be in the platform, right? So it has to be integrated in like matched with the consensus algorithm, etc., etc. So there's like a lot of work going in there, and it's all about not cutting corners. It's all about making it performant. And of course, like we will spend years and years, and actually maybe going back now to the Tritium milestone. So while we had the first version of that, I forget about 2 years ago, the Tritium milestone actually now has some improvements of that scheme here, like the middle one, and really those should be all green now.
Yeah.
So we gotta right after this space walk over to the next room and make sure those things are all green, because they're all live and so on. So we actually managed to shave off like one round of consensus, which will make threshold ECDSA like 1/4 more throughput and less latency. And actually for Schnorr it will be even like a half, because Schnorr, as I said, is simpler, so it only needs half of those things.
Yeah, that's a good segue into Tritium. And actually, I love just to go back on what you're saying about the different skill sets that are needed to do something like a direct Bitcoin integration, right? There's a cryptography skill set, there's a software engineering skill set, there's a security skill set that's needed, and it's just kind of one of the great things about being here in the office is getting to talk with each party and really get to learn what they're doing and just how broad of
and it has to be usable. So there's a product skill set you need, that there's like a developer experience skill sets you need, because otherwise, you have a signing algorithm, but like if you can't use it as a canister developer, if it's not convenient, if you can't derive the keys. I mean, we could speak for another hour about like all the skills that really need to come together and be very well synchronized. And I think that's also like one of the unique specialties of DFINITY, right? Like back at IBM Research, you had the research department, and then you had the business departments, and those guys hardly ever spoke together. Whereas in DFINITY, it's like all very close. The teams are very integrated with each other, right? There's like it's very amalgamated, and that's also what makes this place unique. People love to work in that environment because there's a lot of super cool expertise, and people get to see that. And that's also why we can actually move that fast and with this kind of solutions that actually fully nail it.
Yeah, love it. Moving on to Tritium. So Sam, walk us through, so we just celebrated this milestone yesterday. Walk us through this milestone and exactly what changed yesterday, and actually maybe even this morning. I think I saw an NNS proposal still out there that needs to need to close. But walk us through like what actually changed with the launch of this milestone.
So I mean, it's the improvements in speed that Jan explained. I think that we have already covered, but the two big novelties that will be visible. And I need to move this to the side here. That are, on one hand, we have now the USDC stablecoin twin, the CKUSDC on ICP. I mean, let's be honest, this spends 3 years and there wasn't really a major stablecoin. There has been various smaller stablecoins. You could argue even cycles were used as stablecoin. But now we have one that is really well known, and this comes in an entire framework to create twins of ERC20 tokens from Ethereum. And why would people care about that? So, I mean, now you can really hold US dollar in your wallet or in your account on ICP. We have already seen a lot of adoption by exchanges, by plug projects, etc. And what I think I want to highlight, which I think is really special here, for transactions with CKUSDC, you don't need any gas or any ETH or any other token. You can actually cover the expense for a CKUSDC transaction with CKUSDC. It's 1 cent a transaction, so it's cheap and it's very fast. And I think that gives a lot of convenience to people, and we would expect that there is wallet applications that can now, you can really tip and pay and make transactions in US dollars instead of the other cryptocurrencies that sometimes have you only get very small numbers. So that's one thing. And then on the other hand,
let's try that. We've created a open chat group called Chain Fusion, I guess, Kyle. Yep. And everybody just join that group, and I'll pick a few random people and send them, not a large amount, but $5 each or something, a few people, just so you can experience how fast this is and how cheap it is. One transaction send is just on an open chat message. So let's do that. Everyone join that group on open chat, and I'll send some USDC to some lucky people.
Yeah, cool. I love it.
Then while we wait for the first messages to arrive, I keep talking about the RPC canister.
Sorry, Sam, you're going to have to hold on because I need to get into this group and see if I can submit myself for the $5 raffle. No, that's so if just to repeat, Jan's got some CKUSDC, and he's, if you get into the open chat Chain Fusion group, just drop a message and he's going to, I guess it's really like a tip feature, or you can send USDC as a text chain, as a text message, basically. So go ahead and try that out. Sorry, Sam, go ahead.
Now we have you, Kyle, and 2 other people so far, but
it's not enough.
Keep it going.
There is a delay. There's a few minute delay, so people are just now starting to hear it. So we'll see. We'll see how many people. It's a live experiment. We'll see how many people jump in.
Cool. Let's hope there's many. Okay, so for you mentioned some NNS proposals, Kyle, and I mean there were NNS proposals that adopted this CK ERC20 Minter and Ledger. That happened actually earlier this week. I don't really remember which day, but that allowed for community projects to integrate with CK ERC20 for the celebration yesterday. And then the other proposal that I think is also really important, and that's much more interesting just for developers, is this EVM RPC canister. And what that is, it gives developers a canister API, so you're interacting with another canister on the IC, and that canister then uses HTTP out calls to reach RPC endpoints, multiple RPC endpoints, so we don't just rely, as we mentioned before, on a single point of trust. And they then call into EVM chains, Ethereum, but also others are supported. And thereby, you can now quite conveniently, as a developer, interact with EVM land from your normal canister environment. And also here, to avoid that this is under control of a single entity, there is a proposal, I actually don't know whether it was now voted in or not yet by the community, which is about putting the EVM RPC canister under NNS control. And then the developers, or actually users that use these RPC endpoints, are not at the mercy of a single entity, be this DFINITY or anyone else, to interfere with their EVM interactions. So these are the 2 milestones. Again, CK ERC20 as the first CK USDC as the first ERC20 token twin on ICP, and the EVM RPC canister, which is especially interesting for developers.
Awesome. And just to be clear, right, so the EVM RPC canister, that actually opens up pretty much integration with the entire Ethereum ecosystem, right? L2s, EVM. In terms of the strategy for when to deploy a new or integrate with a new chain, is it I know we started with Optimism, Base, and Arbitrum yep. to begin with. I can't remember if we did.
And Ethereum as well, obviously, right?
Yeah.
Oh, okay. Yep. Is it kind of is it I don't want to say trivial, but easy task if a new entrant comes in and starts gaining a lot of market share,
yeah.
to integrate with them as well?
Yes. I mean, of course, this canister relies on the availability of RPC endpoints. So the RPC endpoints need to support this new EVM chain, and then that can be added by means of an NNS proposal, an upgrade to the EVM RPC canister, to this RPC canister, and then it's available. So it's really fairly easy, but it's not. It needs an NNS proposal, and of course these RPC endpoints also need to support it.
So now that this is live, walk me through how, now that you have a Bitcoin integration and an Ethereum ecosystem integration, like what is now possible that wasn't possible within our industry prior to just yesterday?
Actually, Kyle, maybe we could go to the Chain Fusion page on internetcomputer.org as well. That there's a few examples. I guess Diego coded up some example things where you can, I forget, sell Bitcoin if the Ethereum price crashes, or the other way around, something like that. But essentially, you can do like DeFi on steroids, right? You can have like a smart contract further up that just you post it all. No.
It's this list, right?
Yeah, so that's a list of what you can do. But just the example I was talking about is like on top of the page almost.
Oh, I'm sorry.
There's like some code. Yes, here we go. Right, there's some code example, Motoko and Rust, right? That you could just take and get your feet wet if you want. So these are examples of what you can do already today. So right, like read on like events on Ethereum, and then based on that, like do action or events on optimism and whatnot, right? Consume those events and then sign transactions on Bitcoin, on Ethereum or Arbitrum. So submit those things. You can do, I don't know, like DeFi on steroids. You can have like an AI smart contract on ICP that then does a AI trading bot in a decentralized fashion. And I guess we could just go through all the use cases, but maybe people just want to do that like in peace and read it then.
Yeah.
But maybe I can take just I take a very basic example, but still I think it's powerful. So on ICP you have randomness, right? And randomness it may sound simple, but it's actually not, especially in a decentralized system. So you can create now a random value, and you could do that in a canister that has no controller, so it's really autonomous, right? And you could use timers to just send this random value as a seed or something to a smart contract on an EVM chain. And timers and randomness now is being sent to a smart contract on ETH. Prior to what we did, I think you needed to rely on a centralized solution to accomplish this. And now you can actually extend your dApp with such functionality, which previously you probably did on AWS or some other cloud environment. Now you can do it in a truly decentralized, truly autonomous fashion and augment your smart contract on an EVM chain. Of course, I understand this is a very simple example and it might sound trivial, but think what this enables, right? This is just the basic building block that allows you to do then so much more.
Yeah, I love that idea of just this simple building block solving problems for other chains, right? So instead of a developer having to pick and choose, 10 different solutions to solve 10 different problems, they can pick and choose one solution to solve all 10 problems, depending on what type of app. There also seems to be a lot of power in the fact that you don't have to commit your project to a specific ecosystem, right? That you can easily, if the market conditions change or your product needs to change, you can easily pivot to a new chain, a new ecosystem. And so just all the flexibility it provides for an entrepreneur and for a developer is amazing.
Yeah.
Let's move. So Tritium. So now we've got Bitcoin, Ethereum. If we go to Deuterium, yeah. We're going back to Bitcoin. So walk us through this milestone. This is the next one. We have a date set on it already, so it's coming soon. What is this milestone here?
Maybe that's for you, Schnorr.
Yeah, my most favorite signature scheme by Klaus Schnorr. So right, I guess Schnorr is just like a different signature scheme, and historically, ECDSA was invented because Schnorr had a patent on his signature schemes. That's why they crucified his algorithm in a way that they didn't fall into the patent. But here we go. We have Schnorr, and then Bitcoin uses Schnorr, right, for ordinals, right, and and like many other chains actually use Schnorr. So this Schnorr is not only used for Bitcoin, but also for other things. And actually also EDDSA essentially is Schnorr, which is a little bit different. So they're very much combined. So with Schnorr, we'll be able to hold Solana as well, and Rune and Ordinals. And so that's like coming up next. I think it's super cool. It will be faster, more throughput as well. But again, at the end of it is a different signature algorithm, a different threshold scheme as well, because it's like simpler than ECDSA. But at the end of it, it's just like another parameter in your set of signatures API that you want to request.
I love, when you're talking to a serious cryptographer when they have a favorite signing a signature system or protocol.
My God. Yeah, let's not go there. You get a quite different list of my favorite ones, but anyway.
So that almost basically rounds out the different signatures required for Bitcoin at that point, correct?
Yeah, exactly. I think that's the main one that we need. I mean, I guess Bitcoin has ECDSA as well, but Schnorr, I think it's really a game changer for many things here, and in particular also because of EDDSA that comes along with it.
So speaking of that, one of the chains it allows is Solana, right? And so if we go to the Helium.
Yeah, but actually, Kyle, I think for the Tritium milestone, what is also important is right now while we have like direct integration with Bitcoin, right? Meaning that like I guess someone has mentioned that already, but meaning that the nodes of like an ICP subnet actually pull all the blocks, so that you get like high assurance like of that the UTXO sets that the canister has access to is really like the one UTXO sets. Like if you have an RPC provider, they could always like give you a fake answer, right? So that's why in the RPC canister we call several ones of them, so that we have this insurance. But for Bitcoin, of course, it's direct, so you will have like a much higher insurance even. But in the past, we only had the canisters only had the UTXO set available, which is a bit limiting in terms if you talk about ordinals and like other functionalities. So that's why the second piece here is like on-chain Bitcoin block headers also available. So that opens a whole other bunch of applications like for Bitcoin, and really makes like ICP, I guess, the best choice to build. Like smart contracts that like do with ordinals, runes, and whatnot. It's just like much easier to use here as well, right?
Yeah, I mean that is kind of maybe I don't want to say the dirty secret, but in terms of with ordinals and I think BRC20 as well, that there's so much important data in the block headers and that essentially everyone's solving those like through like centralized indexers, right? So I would probably guess most products built on ordinals have heavy centralization components, right? So this would allow for the decentralized versions of those to be built.
Yeah, exactly.
That's awesome. I mean, again, decentralization maxis, right? Just really taking a look at where you have centralized components within like an entire product stream, and finding ways to decentralize them is the name of the game for our industry. So.
And if you're not one of those maxis, still have a look.
All right, so then let's just round out the chain fusion conversation with just Solana. This is a milestone. We didn't put a date on here. Is there anything you guys want to commit to in terms of I'll put you on the hot seat of an expectation?
If there's no date, there's no date.
Okay.
Yeah, but I think we should mention that there's like ecosystem teams already building in this space as well, right? So I guess, I mean, I mentioned EDDSA, so that it's not identical with Schnorr, it's a different curve. So that's like why EDDSA is like a part of this milestone. So Schnorr come first, EDDSA come later, but they're quite close. So I think there shouldn't be too much of a gap between those two pieces of work. And then like the RPC things, but also here like ecosystem people already do that. There's a cool team in Istanbul that does GSOL here. So things are already happening, right? And it's really great to see that, like, not only the foundation does great work, but like other people out there do a ton of great work as well. And so we just talked to the team, like, I forget, last week or so. I'm very excited about their work as well. Yeah, just check that out as well.
And maybe I want to make a general comment about you mentioned that the ETAs or dates of the milestones, right? I think we really don't have like a detailed plan for every milestone, and we just haven't communicated these dates. We just don't want to overpromise, but I think the milestones that are currently on this roadmap, most of them are really within reach. So I'm talking about a year or so. There is a few of them, and maybe we'll talk later about AI, that are more in the future, rather show where the journey goes. But for most milestones on this roadmap, it's not just aspirational. We kind of have something in mind what we want to do, and are confident that we will achieve it. But again, we didn't want to just put up dates and then have to change them again and again, because then we also have seen in the past that the community relies on these dates, and they maybe create a new project in anticipation of a new functionality that will eventually be rolled out, and then we're late, we hit some obstacles, and then the community is frustrated, and we want to avoid that, right? So we don't want to get community projects into trouble because of over-optimistic planning on our side.
And also, like, speaking of the roadmap, right? If you go through some of those work streams, right? I mean, maybe can you quickly go back, Kyle, on that screen? You see, like, if you now go further to the right, like here, right? Well,
even there, that's probably, yeah.
You see, like, that there's like 16 future features that we plan to work on. Some of we actually already work on, but they're not part of a milestone yet, right? Because the milestones, really, we want to set a theme, like a story around, like how to use technology also. So it has like an end-to-end story. And we're gonna form those milestones as as things come closer. But there's still like, so if you want to figure out like what's going to happen in the future, there's still stuff here that we want to do, right? But here, really, we don't really have a date, right? That can be next year, it can be 2 years. Of course, like anything like 10 years out, we didn't put down here. These are still stuff that are somewhat in the closer future, so something that makes sense to formulate. If you want to look at the 20-year roadmap, it's really ICP being the world computer hosting all of the world's data, and then that, of course, requires more storage, cheaper storage, more compute, whatever, video streaming capabilities. I mean, we can easily make up a whole list there as well. But it's sort of, like, I guess everybody can use their imagination here, what this all entails to do them. So the roadmap really has like all the concrete steps that we're taking the close futures, and the milestones are where we have clear plans on rolling them out, and the features that are not assigned to a milestone, they come later, and we're going to build milestones around that once we're done with the current milestones.
I love it. Yep. Let's just throw a couple comments up, just so kind of going back to the congratulatory. We've got a Arc of the Eye who's excited over CKUSDC integration. Moritz, who I saw yesterday, had a chance to see him in person, which was awesome, saying Chain Fusion, let's go. He also puts in a couple examples of some things you can do with Chain Fusion. So if you're a developer, check out the comments. Moritz has a few things there. Jan, a while back, you had mentioned the idea that Chain Fusion kind of actually unlocks AI for other chains, right? That the internet computer can be a platform where somebody can build AI, and then because of the direct Bitcoin integration or the Ethereum EVM RPC integration, you get these like abilities to now bring AI to those chains. So let's move the conversation. I'll give some credit to Stan, who says, does ICP have a solution for GPUs with AI? I think we're going to get to that question.
Totally. But by the way, still join the open chat group. I can't dance right now because typing on the phone, I really hate it. But select sending Bitcoin is or sending CKUSDC is easy from the phone, but like anything like answering or something, like we'll have to wait for later. So far we have 16 members. So people, please join if you're interested in some gambling here.
It's free. It's not gambling if you can't lose.
Yeah.
Okay,
so yeah. Maybe some people should send me some money first.
All right, let's talk AI. So we have 2 milestones that are called out on the roadmap: cyclotron, which is the first one coming up, and gyrotron. Let's kind of like circle back and just high level from a program standpoint, like DFINITY standpoint on AI. Where do we kind of stand? What's the vision that we're trying to aim for?
Yeah, I mean, the vision, of course, is to run all of the world's software, and that totally has to include AI, right? I think that's the very cheap answer here. But like, why would you run AI on ICP, right? I mean, because AI is very compute intensive, and of course, if you run AI, a normal network or a normal machine, you just need one machine. Where if you do it on the internet computer, you replicate it like at least 13 times, right? So there's a bit of a price tag here. But I guess the point here is like AI is a different nature of software, right? It's like at the end of the day, because we don't want to go too much into details, but like AI is really just like a huge, humongous matrix where there's like weights in those matrix, and that's what all this is about, right? Whereas a normal algorithm says if this, then that, else this, and so normal code is logic, whereas AI is just a bunch of numbers. and so that if you look at normal code, you can just look at the code, and then you sort of well, some people at least are able to understand what that piece of code will do. Whereas AI, you have no clue. You just see those numbers, and then the only way you can somehow figure out what it does is to try to interact with it, and then you find out. But like if I have like an AI assisting me in my car, I have no guarantee that it wasn't sort of trained to like hit somebody if they recognize their faces, right? So you don't know, right? Because you can't check it out. Whereas normal code, you actually can read the code, and if the code doesn't contain a statement that sort of, if you recognize Jan on the street and fully accelerate, if that piece of code is not there, probably safe. With AI, I don't know, right? I mean, I don't know whether this one value did just change that. So it's quite different pieces, right? But that also means that it has like different requirements in order to make it secure. And the internet computer protocol is all about making things secure. I mean, you don't decentralize something for fun. You decentralize because that gives you, well, two things: higher reliability, right? Because you have like fault tolerance, so it's more available. But also because it's actually more secure, because there's no single party who can single point of failure. Right, and of course, you also want that for AI to start with. So you want the AI be available, but then there's this other aspect, the security, right? And so, how can you make sure like an AI model is really secure? And the only way to do that, if you train it in a trustworthy environment, right? And that's really the end game here, right? Have AI on ICP such that you can build AI in a trustworthy environment, so that later on you can really be sure this AI doesn't show porn to my kids or something like mundane like that kind of thing. You just really want to be able to rely on it. Has to be a reliable part, right? And so if you want to contain AI, it has to run, has to be trained, has to be built on a secure platform. That's the end goal here.
I'm laughing at the idea of somebody taking one of those cars that goes around and just collects data for building self-driving AI, and that they have a picture of you that they're just accelerating towards every time, just to get that in the training data set.
I'm laughing not so hard here, Kyle. But maybe I'll hack it and exchange it for your picture.
Yeah, I know. Well, that's well, now I. Yeah.
No, but I think that kind of attacks. I mean, it's like, I guess AI are crazy, right? If you think about smart bombs or smart drone bombs that are small enough, I mean, there's a lot of scary aspects about AI, and I think people do get scared, and I think for the right reasons. And I think that's why, at DFINITY, we really want to solve the world, address the world's hardest problems, and like security, and in particular in the context of AI, are one of those world's hardest problems. And so that's why we are working on securing AI as well.
Awesome.
Maybe
I
I think we often describe it also as sort of a black box, right? And the trust problem in AI, what Jan described, and sort of making this black box less black or transparent, that you have assurance and trust what went into this box.
Yeah, and that definitely seems to be on target with, you start to see like the ChatGPT 4.0 come out, and you start to
Kyle, can you add the name of the open chat group again? It seems some people don't really.
Yeah,
I forgot that.
Thank
you.
I can't edit live. Yeah, so just chain space fusion. If you're looking for the open chat group where Jan is giving away his hard-earned money. With AI,
not all of it, just to be clear, right?
Let's dive in deeper. Actually, I will say too, like there's the decentralization aspect is obviously a huge concern. And Jan, you touched on it so well, of just saying the vision of the internet computers to host the world's software, like that grand vision, and then just recognizing that the world of software is quickly moving towards AI at a very rapid pace. So like the internet computer has to keep up in order to be able to meet that grander vision. I also am really looking forward to when people do really cool things like leverage blockchain's ability to do like cheap transactions, financial transactions as part of an AI, or have like the output of a AI model actually be assigned digital ownership, like minted as an NFT and provided to whoever put the prompt input, that kind of stuff.
Yeah, I want to add here, right? That ICP is really the only platform where you can run AI on the blockchain, right? It's not possible anywhere else. Maybe people claim that, right? But it's just not possible. Well, I mean, you can have maybe like a 2x2 matrix and call that an AI, something like that. But really, I mean, and I think you need some, like you need to get your protocol design right to even be able to do that. And because you mentioned, I mean, obviously, if you wanna train your AI on chain, I mean, you have to have GPUs, right? And the plan here is, and because I'm not sure which gyrotron, whatever it is, right?
Add something here, Jan, because you said you have to get the design right, and I want to emphasize here one thing. There was a very early design decision to use WebAssembly as the virtual machine on ICP. And now we see why this pays off, right? Because now you can use an inference engine for AI, and it's written in some language that can now be compiled to WebAssembly, and you can create in actually a few days. We created the first example of an AI model running on chain. And that's
well, actually, we were not the first, but like our first, like DFINITY's first model, right?
Our first, but yes, let's
Community was
much faster.
Much faster.
But that's thanks to this design decision to use WebAssembly, and then this combined with the scalability and the computational power of ICP allows you to run. I mean, we may have all seen this quite viral tweets of Tom where he showed this picture recognition example, which was exactly this.
Yeah, but I think indeed, right? So that's totally true. And of course, like what I've done so far was all just still running on CPU. But to really like kick the bin here, you have to have GPU access, right? And so the goal here is like cyclotron or Cyrotron or Megatron. It's sort of to have like hardware, like GPU enabled nodes, so that you can actually then submit jobs that run on the GPU and not on the CPU to really make sure you can do learning on like a decentralized network in a replicated way to get that assurance. And so that will, like, I mean, that's what we're working towards. And this has two parts. I mean, I guess getting the hardware is actually the easy part. Well, sort of on the order books of NVIDIA and whatnot, right? It might not be all that easy, but still it's the easy part, right? Just buy a hardware, put it in a data center, hook it up to ICP, done, right? It's like the hard part here is actually to make sure that your learning is actually deterministic, right? Because you cannot replicate anything that is non-deterministic, because then you cannot run on consensus already. So that's like the main challenge here. And you see like all these cards here that sort of list the challenges that we're working on towards that, to really make sure that we can run AI in a decentralized fashion end to end.
Mm-hmm. But let's be honest, I mean, this is a big lift, right? And I think we'll see stepwise improvements. The next step, because of this faster deterministic floating point arms, which is in the earlier milestone, we already expect a 10x boost in performance, which is actually quite a lot, right? If you think about it. But I think you're right, Jan. Ultimately, we need access to GPU if we really want to run big models. And that's a lot of work, right? So that's why I think this Gyrotron milestone is one of the most aspirational ones, which is further out and may actually over time be decomposed into some intermediary milestones towards that bigger goal.
So Jan, you'd mentioned about other chains claim to be doing AI. And I mean, just from investigating, I would say 90% of those claims are basically, we have a token on a ledger, but then we have ChatGPT plugin or something, right? Like that's basically the design of what a lot of people are claiming to be decentralized AI. Is it, just thinking about, Sam's talking about like how much work we're trying to get done to kind of keep up with what's going on in Web 2. Is there any concern over like another project leapfrogging the internet computer in terms of AI? You see like some of the other chains, L2s on Ethereum or standalone L1s are making claims of, their own AI programs. Like how nervous are you in terms of their ability to execute?
I don't know. It's a difficult question, right? Like, do I know what happens in the world, what I'm not seeing? No, I don't, right? I mean, like, I'm not sure what's cooking in whatever Middle East, China. I don't know, right? I mean, so in some sense, of course, like there's like smart people out there everywhere. On the other hand, like ICP already is built upon like thousands of hours, like person hours of years of research, right? And so you don't just copy paste that, right? I mean, it requires a lot of intricate knowledge to actually pull this off. And then again, of course, you can cut corners, right? I mean, I can build like a token. I can copy paste a token chain and then have a few GPU machines and then somehow interact with them. I mean, you can something maybe that you can market out of. Like we have like AI on chain. Like, I guess you're getting the bigger picture here. Like people say this is on chain. Typically, it has like a ton elsewhere on Amazon and whatnot. Some of the nodes even on Amazon, I guess. And they have some token somewhere, right? And then that's why they call it like blockchain powered AI and so on and so forth. But it really means like blockchain powered is like, yeah, you need a token to pay for AI learning, whatnot, right? So at the end of the day, it's not easy at all to pull something like that off. And like DFINITY has like the best R&D team in the world. I guess in this space at least. Even if you look at cryptography and distributed systems research centers, like no university comes close either. So we have like a unique team. So from that point of view, I'm not scared at all. Like, so somebody can like actually beat us to the tech, right? But of course, like people can claim the sun is black, and what can you do if they want to claim the sun is black and run with that? Be my guest, right? But I guess in the long run, people might notice that, yeah, if they take off their sunglasses, the sun wasn't black after all, right?
Well, not here in Zurich, at least. I've yet to see the sun in all my trips to Zurich. So I'm going to have to take your word on it that it's not black, at least while I'm here. So like Sam, you had mentioned about just the decision to do Wasm, right? Like that was you choosing the hard path, and how now that has paid forward. Now that AI has become a bigger part of what software is, and so is that kind of like a key advantage of perhaps the DFINITY approach of like, look, we're going to do the things the hard way, the right way up front, because like John said, our vision
I
is
think so. Well, I wouldn't say Wasm was really hard as such, but it was a universal framework that now you can reap the benefits, right? Because other people have already built a lot of cool stuff that now you can just use. And this combined with the computational power and then let's say non-deterministic time slicing, right, is where you can really run into multiple rounds, a long-running compute. These are all ingredients that were built over these last 3 years since launch that now you can benefit by putting this all together. And I think these were smart design decisions that pay off, basically. Yes.
Awesome. Anything else you guys want to touch on AI? I know we're running a little bit long here, so I want to be respectful of your time. But I also don't want to get off this topic if there's another point.
Maybe one last thing. We are working on this now, but we actually also plan to grow in this regard, and we are recruiting and we are interviewing very interesting candidates. But maybe if someone is out there and listens to this and feels this is a problem that I would like to work on and I'd like to be part of this world-class engineering and research team, join us.
Awesome.
So Kyle, let's do this like CK USDC kind of thing.
Yeah.
We have a number of group members here, and give me some whatever. Just say stop a few times, and I mean, I have there's somebody called Fully On Chain. Like this guy just wins by the name. Congrats, Fully On Chain. You're a lucky winner of $5. I'll send it in a second. But like I'll pick 2 others and then just move my finger on the member list here, and Kyle just say stop any minute, and I'll make a pick.
Stop.
Okay, Danny Boy 88 is the next winner.
Awesome.
I'll do that. Okay, let me just send it so we can also see this thing, and then we'll do it once more.
I see Kick 1776 is asking if we got a chance to meet Beetle 89, James Beetle, creator of OpenFPL. I met him yesterday, actually. I think Kick should get credit for calling out a great developer in the ICP ecosystem.
So you want to select this person? No, we have to do it randomly. No.
All right.
No, whatever. If you send me $5, I take $5 as a bribe, Kyle, to take your picture.
Do you need me to say stop again?
Sure.
Or do you want to keep it going and maybe pick a few random people? Because we'll get the majority of the watches of this will be, in the next 24, 48 hours.
We just have Fully On Chain as a winner now, and then Danny Boy as a winner now, and then I'll do something later tonight so people who are not watching this live have a chance as well.
Awesome.
It makes it fun, right? Maybe I might do it on Saturday or Sunday. Who knows, right?
So if you're watching this, just join that group. I mean, if anything, I want to just highlight, and this was such a phenomenal idea by Jan. Right before I hit record on our stream here, Jan was like, hey, do you think we could just set up a really quick open chat group? But just that kind of points towards the incredible products being built on the tech stack. You can send as a chat message some USDC, and it happens in a couple seconds. You can do it live on screen. So it's just a phenomenal idea for highlighting what OpenChat has built and the speed of finality of CKUSDC. Enjoy. I hope everyone enjoys their CKUSDC. What do you guys? Is there any? If I put you on the spot and say, okay, you can't say chain fusion, you can't say decentralized AI. What's the other what are we calling these? Pillars or verticals of the roadmap what's the one that gets you most excited about?
ICP.
Just ICP in general?
It's the base protocol. The first one is all about ICP. Compute platform, right? But it's really ICP, the Internet Computer Protocol.
Oh, I see. Yeah, yeah.
I want to mention then the one at the very bottom, developer experience, right? So I think we and Jan knew that.
You can't stop talking about developer experience every time it comes to my office. We have to do more developer experience.
Well, we only get adoption if people build and if developers they have a great experience doing so, and hopefully the party was also a good experience, as you mentioned earlier. No, but this next milestone is all about sort of the life cycle of your canister. And frankly, we are not where Web 2 is in this regard yet, right? So, but this milestone brings us significantly closer. You will have logging, you will have snapshots of your canisters. So you will have much more insights in what is happening in your canister as it runs. And I think that will really be a major improvement in the life of developers. And ultimately, I really want ICP to win a lot of great developers because they will build great products and that will hopefully then attract a lot of people. So that's why I wanted to highlight developer experience.
Yeah, at the end of the day, the developers are who make the platform valuable, right? So
exactly.
they add value on top of the tech. I do want, Marcus had sent this really at the start of when we first started showing it, and I think the design team who put together this roadmap actually deserve a nice round of applause as well.
Absolutely. And maybe I want to go back to an earlier statement. Jan, you were saying how we work together at DFINITY with a lot of great people and across teams, but also like the work on this roadmap, right? It took a lot of time to get there. And also what's the right format, what's the right naming, having these names inspired by Fusion, but then also how do you present it? And here you could also see there was a bit of we had to find a good compromise between a design team that cares a great deal about having a great, pretty design, and I guess more the R&D side that is like, okay, give us pages and pages of text where we can describe in every last detail what this feature really does. And the design team is like, yeah, but maybe nobody wants to read that. And so I think we found a good compromise here, and I'm happy to read that some of our listeners...
He is totally lying, because I care a great deal about the design as well.
Yeah, you guys are getting a lot.
Actually, let me mention one more thing, because I guess I just saw a message flying by when we will come to the Netherlands. Actually, we will come to Brussels at the ECC in Brussels next with the Chain Fusion Day. I know it's not quite the Netherlands, and I know the Belgians and the Dutch hate each other, or at least they joke about each other, which I appreciate a lot. So we'll be at the ECC in Brussels, and we have like a Chain Fusion Day. So Chain Fusion Live will be in Brussels as well, a whole day. So please join us there and learn about all of Chain Fusion and some examples of how what people built already on ICP together, like integrating with other chains, cross-chain stuff. So please come there. It's going to be an exciting day, and because we also have hacker houses in front of it. A lot of activity around these Brussels. So really want to mention that, and personally looking forward very much to that day and the event in general.
Yeah, and I'll just give a personal plug. I mean, getting to come here to Zurich and to see you, Jan, getting to see you, Sam, like you guys, even beyond just the phenomenal tech you're building and your vision for the future for DFINITY, you guys are just really fun people to be around. You're really good to talk with. So if you have a chance to meet either of these guys at a conference or at a DFINITY event, if maybe at the 4th birthday celebration or something like that, I definitely recommend seeking them out, because they're very enjoyable people to be around. And I want to thank you guys. I'll give you guys just maybe one final thought. Like, we talked a lot about vision and everything around the internet computer, the excitement over the roadmap. Just in terms of like final thoughts, wrapping up this incredible week, what do you guys want to say?
ICP.
Well, maybe I want to say one thing about just closing on the roadmap. We my turn. I take a few more words. No, but I think having this roadmap and having these themes allows us exactly to have the discussions we were just having, right? Where are we going? Why AI? Why chain fusion? And this is great because it's not just, oh, we throw a bunch of tech out in the world, but why do we do it, and to what end, and who can build what? And you asked a really, I think, important question, Kyle. You know, what is different now that this milestone is achieved? And I think in the past we were maybe not so good at explaining that. And I hope it allows us to work closer with the community. It allows us to explain better why certain things are done the way they are. And I think that we have started that exactly this week. Yesterday was a great example with all these community members. Today, this hour was such an example, and it makes me very hopeful for the future.
Awesome.
Right, and like, of course, every milestone comes with a party. So like, where we can say, "Long live ICP."
I have a feeling the team that put on yesterday's party is going to say, "Wait, you want to do this every milestone?"
Totally.
Jan and Sam, this was a phenomenal time. I really for your time. I enjoyed this a lot, and I hope the community took a lot from it. I want to thank the viewers and for all your support within the community, for your interest in the internet computer. And as Jan said, go ICP. Like, there's probably no better way to sum it all up. So thank you guys so much.
Thank you.
Bye-bye.
Bye.